Our next presentation is Accelerating UFS and MIPI UniPro Interoperability Testing with Rui Terra of Synopsys. Rui is currently an R&D engineer in the IP prototyping team at Synopsys. He received his MS degree in electrical and computer engineering from Polytechnic School of Engineering in Porto, Portugal. So please, everybody welcome Rui Terra.
Thank you. Hit the button. Yeah. Hi everyone. I'm Rui Terra. I'm here from Synopsys. I work as an R&D engineer in a prototyping team, IP prototyping team, and I'm here to present Accelerating UFS and MIPI UniPro Interoperability testing. Okay. In this presentation, we will cover the following points. We'll start by the mobile storage market landscape. We'll move into why it's so important, especially now, to achieve UFS device interoperability and compliance success. We'll look into how to accelerate your UFS designs, development and verification, and finalize with a summary. The mobile storage market landscape is divided into main segments, the embedded and removable. In the embedded, it's like the disk of your mobile, and removable is the removable cards of your mobile. In the embedded market, the MMC has dominated the market, especially in mainstream and low-end market. MMC is still being adopted, especially due to improvements in the latest spec. Nevertheless, it's been seen the UFS starting coming out with the high-end smartphones due to power, performance advantage, and security features. On the removable market, the SD has dominated the market. Nevertheless, the first UFS cards were announced and are expected to be widely adopted. Here is the performance in the embedded solutions in the recent years. As you can see, there's been an increase in performance in the recent years, especially due to the requirements of mobile applications. In here, you can see the current UFS spec that is higher in performance than any of the existing AMMCs. And this is only one lane, meaning that if you have the two lanes, you can achieve the 1.2 gigabits per second. The following spec will support highest speed Gear 4. In the removable side, the SD cards has dominated the market in a variety of applications like mobile phones, cameras, tablets, computers, you name it. Ultra high speed 2, the latest class speed from SD cards, has seen a low adoption due to increase of complexity and niche use in high-end cameras. Like I mentioned, the new UFS cards have been announced and are expected to be widely adopted due to increasing performance and capacity. It's important to notice that UFS has the ability to, in runtime, change the speed, so you can have the performance required for your application while lowering the average power consumption. It's also important to notice that the UFS cards are not compatible with any of the existing SD cards. Nevertheless, UFS cards have the pads positioned in such a way that you can, that is possible to have a combo socket that enables to use UFS cards and micro SD cards in the same socket. I think this is very important for a transition period and also to enable UFS cards. So let's look into why it's so important to achieve UFS device interoperability and compliance success, especially now. The UFS Association, has announced the CTM, the Compliance Test Matrix for UFS interoperability. So as you can see, there's an interest from the market to have a well-defined program, a well-defined document that specifies the requirements to achieve compliance and therefore ensuring UFS interoperability. And that's exactly what the CTM is. UFS is composed by three main building blocks: by the UFS as an application layer, by the UniPro as a link layer, and MIPI as a physical layer. Each one of these documents has its own test document. So the CTM refers the tests from these documents that are required to achieve compliance. So why is it so important, especially now, to have this program? Until now we had the embedded solutions. While you still need to do bring up and interoperability tests, when you have your solution working, that's it. It's a closed control solution. With the memory cards, that's not true anymore. Your UFS device has to work seamlessly with any host in the market. That's why it's so important to have a program and a document that specifies requirements, especially now. Here are some of the bring up and interoperability tasks that you can do with your device solution, between your host and your device solution. I choose these ones because of their importance, but it's just a summary of them. There's more, of course. When you have these tasks working and the required tasks for your solution, you have some confidence in your solution. And it's important to notice that these tasks are not easy and fast to perform. Like the link startup sequence, power mode change, DMA access, or hibernation entry and exit. This is not fast and easy to perform. And I have seen users spend multiple weeks to do just the link startup sequence. Nevertheless, the link startup sequence is the first big step. Once you have done that, you already are capable of doing DMA access, you are already capable of communicating bidirectionally between the two nodes, and after a successful link startup sequence, you are ready to communicate. So, since this is such an important task, let's look a bit into it. The link startup sequence is a UniPro sequence to establish the initial link between the two nodes, UFS host and UFS device. It's an extensive procedure, like we will see in next slide, and it includes multiple bidirectional handshakes. But after you have done that procedure, you are ready to communicate. So let's look into the link startup sequence, single link startup sequence. For you to achieve a successful link startup sequence, you have to start from an enable state in both ends. When you want to do the link startup sequence, you do a link startup request that will make your TX lines on your MIPI exit the Hibernate state, and it will issue a line reset. And then we'll start the trigger pattern exchange. And that will be seen by the device side as a link startup indication. And then the device side will do its own link startup request automatically. And we'll do the same. We'll take its TX lines from hibernation and then perform a line reset. And then both nodes will go into trigger pattern exchange. The trigger pattern exchange includes lane discovery, lane realignment, and termination phase. And once that is done, you go into capability exchange. And if all of this procedure was successful, you have a successful link startup confirmation. So as you can see, it's an extensive procedure that includes multiple bidirectional handshakes along the sequence, and it's complex and time-consuming. So the sequence itself can fail for multiple reasons. It can fail in the sequence itself. For example, if one of the nodes were not able to exit the Hibernate state because a proper reset was not done to the misconfigured MMCs or RX lines, because an out-of-order trigger pattern exchange, because a capability exchange failures, or incorrect timeout. It's important to notice that even the link startup sequence is protected by a 100 milliseconds timer. It can fail also due to integration issues. For example, it may have incorrect IP integrated, wrongly dimensioned memories, wrong constraints, you name it, or due to interface timing issues. So if you have UFS host and MIPI that that are working, that's tested, and it's working, and you want to test that with your device, you don't need to worry on the host side on the sequence if it's a non-working and tested host. But if you don't use a prototyping setup that is working and it's known, if you do it from scratch, you can have the integration or the interface issues. Like I mentioned before, I have seen users spend multiple weeks on the link startup sequence, and they were using a non-working UFS host and MIPI. And they were sure that the integration that they have done was correct. They were sure that the MIPI that they were using was working correctly, and they were sure that their UFS host was correct. And in fact, they could see the correct data coming out from the controller interface with the PHY, but they could not achieve a successful link startup sequence. And after multiple weeks debugging, they had an interface timing issue between their host integration and the PHY. So this delayed multiple weeks for what they wanted to do, that was testing their memories from the beginning. So let's look a bit into the CTM itself. The CTM, like I mentioned, is a reduced matrix. The CTM the UFS is composed by 3 main building blocks. Each one has its own document with a set of tests. What the CTM did was reducing the number of tests necessary to achieve UFS compliance, but they wanted to do this without compromising the test quality. And they did that by eliminating redundancy, for example, and also eliminating not required tests for the UFS solution. So the CTM provides a clear definition of which tests are required to achieve compliance, and also reference to the procedure itself, so you can achieve compliance and ensure UFS interoperability. This image is an extract from the UniPro part of the CTM. And let's analyze one of the tests of the CTM. I have chosen one of the tests, the Hibernate test, that is the 1.3.1 from UniPro CTS. And for you to achieve a successful Hibernate test, or a successful 1.3.1 test, you have to start from an enable communication between your tester and dude. What this means is that you have to achieve a successful link startup sequence, the one that we analyzed before. Once you have done that, the second step is to change the default values of some attributes, because in Hibernate, Hibernate is a ultra low power state from UniPro, And when you go into Hibernate and you come from Hibernate, you should still keep your configurations. So in this test, you will write some values, and after you go into Hibernate and exit Hibernate, you will see if that values are kept, the attribute values are kept. And if they are not, that's not a successful 1.3.1 test. So these values are specified in the UniPro CTS. You have the attributes and the values. You just need to set that attributes with the specified values. Then you read back the values to see if you could successfully return that values, and only then you request an hibernation entry. Then you analyze the PCP package exchange, and then you verify if you are capable, or if you really are in hibernate state. Then you request an hibernation exit, and at the end you check the values, the attributes, to check if the values that you have at this point match the values that you had at this point. And then you do this procedure in multiple power modes. I have resumed here the procedure for you. So the test itself can fail because you are not able to go into hibernate state, because you are not able to exit hibernate state, or because the values don't correspond to the values in step 3. So let's look into how we can help you to get your memories ready for compliance. We have what we call the IP prototyping kit. It's a working out-of-the-box prototyping kit. In this case is the UFS host. And the prototyping kit includes a reference design with all the auxiliary logic, integration, timing constraint, generation scripts, everything you need. It has a tested and working out-of-the-box bit file, and includes multiple things like FPGA platform, MIPI, daughter board, all the auxiliary material like the cables, and it's ready to start working out the box with your memory. Because customers can get kit, plug it in, connect to his Linux, insert the drivers that come as a reference, and start using our application and to stimulate your memory. The prototyping kit includes a MIPI daughter board that has 2 TX lines and 2 RX lines. It comes with a FPGA prototyping platform that comes with a bit file that was tested and proven before. It has all the auxiliary materials like interface cables. It comes with an IP reference design, a proven IP reference design, with a reference driver and a software application. It's important here, the software application has a set of commands that will help you to get your memories ready for compliance, because we can create the necessary stimulus. The prototyping kit can come in multiple interfaces, like PCI to connect to a computer, like in this image here. It can come with an AXI interface to connect to a ARC platform. It can come with a PCI interface to connect to a computer that uses a virtualizer that enables you to emulate an ARC or ARM processor, and it can go up to Gear 3 Rate B, and it supports 1 or 2 lanes, RX and TX. So let's look into how this can help you perform the test that we just looked into. And get your memories ready for compliance. So on this side, we have the test that we looked before, and on this side is some of the commands that come in the application. If you look to the commands here, the three first commands, you have VMA reset, VMA enable. These two first are what you need to have the host in the enable state. The third command will request the link startup sequence and will perform all the sequence that we analyzed before. Then you have the VMA get and set commands that are what you need to set and get attributes. So you can do step 2, for example, or 3. And then you have the peer commands that is exactly the same, but you can set and get attributes on the device from the host. And at the end, you have the hibernation entry and hibernation exit that will issue the hibernation entry request and hibernation exit. So at this point, is just following the flow specified in the CTS and put these commands in a script, and you have what you need to perform the 1.3.1 test. It's as easy as this. So let's look into some more tests. Here we have the UFS UPIU 01 test. This part here was extracted from the CTM, and this part from the GDEC document 224. So here the GDEC tells you that this test is required for all the devices out there. This is retired from the current CTM, sorry, and the next CTM will probably add here the UFS 2.1. So in the GDEC document, you have all that you need to know about the test itself. It tells you the purpose of the test. So UFS UPIU 01 is essentially a ping, is the handshake of UFS host and device, and that is an opt-out. When UFS host sends an opt-out, UFS device should answer with an opt-in. So it tells you what is the purpose of the test. It tells you the procedure and the input parameters. We don't need to worry about that. We will look into why next, and then we have the expected output. Let's make a mental note here. So the transaction type should be 20, and the flag, the response, device information, and data segment length should be 0 for a successful UFS UPIU 01. So all you need to do with UFS IPK is to use the following two commands. The first command will do the knopout command. That's why I told you that you didn't need to worry much about how to do the test, because with this command you can do it. I'm issuing the knopout to the doorbell 31. So UFS has 32 doorbells. I choose one randomly. And then I got UTP command descriptor of the doorbell 31. So we could analyze the answer, the response of this command. The get UTP command description has a lot of information. I select here the information that we require to see a successful, if the test was successful or not. That is response transaction. So as you can see, the transaction type is 20. The flag, the data length, the response that is here, the device information, and data length is 0. So with just these two commands, you can see if you are capable of having a successful UPIU 01 or not. And this is a successful UPIU 01. This slide is a success story from a major semiconductor company that used the Synopsys solution, and the SK Hynix had the requirements to use a proven and quality solution to reduce risk, quickly achieve volume production, meet aggressive power and performance requirement for a UFS solution, use a solution compatible with JDEC and MIPI standards to easily achieve interoperability. And all of these requirements were met by using the Synopsys solution. According to Mr. Park from SK Hynix, he's a senior engineer at SK Hynix, they were able to speed up their schedule by 6 months due to use of Synopsys solution. So in the end, use of a proven solution enable SK Hynix to achieve interoperability success in a short time. So let's look into how we can accelerate your UFS design development and verification. In a prototyping solution, this is the normal schedule. But this is assuming that you already have a known working IP that you will integrate and that you have a PHY. So in this prototyping, assuming these two things, you will have to create a reference design that integrated the IP, create a daughter board for the PHY. You will have to validate that design and these two working together. Only then you could explore the IP configurations, and only then the software team will have access to some hardware that they could work on. With the prototyping kit, we eliminate these three phases and give you a known working setup working out of the box. So the hardware engineers can right away working on exploring the IP configuration, and the software engineers already have hardware working and a software reference and an application. So they can work on that if they want, or they can move directly into the interoperability and compliance testing. Okay. So for hardware engineers, they can learn about protocol because they can explore configurations, they can deep dive into it and not create everything from scratch. They can test different product interoperabilities and debug their logic. And for software engineers, they can start working right away and develop firmware and test different products in connectivity. So essentially, both hardware and software engineers can directly go into explore and test interoperability with their memories. The reference design from the prototyping kit includes documentation, test bench, the reference design, a pre-built FPGA image that you can start working out of the box. The software comes with a Linux OS driver, application examples, and compilation scripts. So let's summarize that presentation. So it's clear the importance of compliance and interoperability, especially now that we have the memory cards out there. Because now the solutions have to work seamlessly with any host on the market. Synopsys IP is the reference solution in the market. Most application processors with the UFS host capability use Synopsys IP. A vast majority of device and controller companies use the prototyping kit, UFS host prototyping kit, to validate, debug, and test their UFS device solutions. And Synopsys is the only IP company actively participating in JDEC and UFSA meetings and workshops. We have here in Synopsys booth UFS prototyping kit, so if you want, please go visit. We will be more than happy to answer your questions and showcase you the prototyping kit. So it's clear that UFS is growing now that the first UFS host mobile phone hit the market, high-end mobile phone. The first cards were announced and are expected to be widely adopted. But developing devices with seamlessly interoperability and compliance is difficult. It takes a long time. It's complicated to do. It's extensive procedure. And with the UFS IPK or prototyping kit, we want to enable you to validate your device solutions and to enable them. UFS prototyping kit is a complete reference design working out of the box. It has a fast iteration flow, so you can easily change your configurations and have a new bit file, and you have the software capabilities, the driver and the application that can enable you to have your memories ready for compliance. Thank you for your attention. I have been talking here about UFS solutions, but we have a broad portfolio in the MIPI. So if you want to know more about, go to our website or visit us at the booth. Thank you.
Any questions for Rui? All right then. Rui, thank you.
Welcome.